All right, so this is going to be this should be the first update on the first little project phase of my little auto slide rule project. So what we got here is everything catted, and everything, finger quotes, but it's coming along. Most I should say we have all the important things catted. I'm going to go through and replace, just in the next couple days, going to go through and repair this vector extrusion I have on this front plane. And as you can tell, the Autodesk Fusion 360 is like destroying my computer, but you learn to live with it, I guess. But yeah, so this extrusion, I'm going to repair it. Like you can tell, there's some weird arcing going on. And some of the zeros aren't showing up because of a related problem. I think it thought that there were some vectors that were adjacent and attached, but really weren't. I need to investigate that one a little bit more. But other than that, yeah, everything is just about done. I might tweak a couple little things, but yeah, nearly everything's ready to go for a laser cut and everything. So what is this slide rule? So, well, if Fusion 360 doesn't crap out entirely on me right now, anyways, so I'll just go ahead and explain. So what you got on the slide rule is, I would personally look up a proper demonstration of how to use a slide rule, but the gist of it is you have these logarithmic scales along the length of it. Looks like a ruler, but it's a log function. So you can see the 1, 2, the 3, 4, 5, 6, 7, 8, 9 get denser and denser, and then it jumps over to the next set of how do you say, the next decade, I believe they call it. Yes, so the next decades and the next set of 10. So this would be 1, 2, 3, pi's right there, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70. And you can see it's not a linear scale, it's log. And this is very important to how the slide rule does its math. So you got your little sliders and stuff, right? So if you want to multiply, say, let's say, oh Jesus, is Fusion totally crapped out on me right now? Let me check. Yeah, that's not good. All right, so okay, so it's not dead entirely. So if I were to do this, and then if I wanted to multiply, say, I don't know, 4 times, let's say 6, maybe. Yeah, let's go 4 times 6. So what I do is I would take our middle slide and I would take it and move it so that no, don't let me move stuff. What are you doing? Oh my god. Oh my god. Yeah, Fusion is weird. It's just way too hard for my computer. It goes ham. Come on, go away. Yeah. All right. So is it still crapping out? It's all right. So if I were to want to do that multiplication operation, I would take the slide and slide it so that 1 lines up with the 4 up there, right? 1 to the 4, right? And then I would take my little needle and I would take this thing and slide it up to 6 over here. And what you end up with is, and you can't really see through that needle very well. That's just because of the way Fusion renders the transparent stuff. It doesn't make it that transparent as much as I would like it would be. But anyways, you got 1 to 4, and then you got go up to 6 over here, and you go up to the top row again. So what you end up with is, let's go, so that's 10 right there, right? And then 20 is right here, And then 20, 21, 22, 23, 24. Would you look at that? What a coincidence. 4 times 6 being 24. What with the line lining up there. And it's not perfectly lined up because I didn't adjust these all perfectly. But you get the idea. And you can do all sorts of operations. Like it even has like tan and cotan functions. I'm not going to demonstrate that because honestly, I've never done it before. I could probably figure it out after, tinkering around with it. But yeah, as you can imagine, this is more of a because I can and I feel like it project than a desperate need. Because just simply because it's a slide rule. We've had digital calculators for years now, and they're really not necessary. But I just thought it would be funny to make an automatic slide rule that has the little calculator interface and whatnot. Now mechanical design. Let's get into that real quick. So the way that this thing is actuated, and I haven't fully modeled the actuators because I don't need to per se. I'll just kind of wing it as I go. But oh my god, Fusion, quit crapping out on me, buddy. Anyways, the way it's mechanically functions is that you have on the back side, well, you have those two big steppers at the end, right? And on the back side, you have them on little pulleys, right? And then now this big wooden circular block is actually supposed to be an aluminum pulley, but it's about the right diameter and I just stuck it there for now just to, get it, I don't know, so it makes sense, I guess. Again, one of those things I'm going to figure out as we go. But the idea is that you have little belts, just like GT2 timing belts, and then there's this weird serpentine pattern I had to do to get the belt from the stepper to go around these two pulleys here and here at either end, and that's what this plate is for. Is it kind of organizes that serpentine path. And that is for driving the middle slider. The one for driving the needle, the big needle slide in the middle, or the one that's vertical, is this stepper on top, and this one just simply goes up across a little bearing there. It's going to go to another one at the other end. I need to model that real quick, but come back down, get clamped onto the UHMW block. I believe at this moment I'm probably going to go with UHMW, either that or some other similar plastic, but that's just kind of what I'm leaning towards right now. Anyways, it would bolt to that and then come back around. So this would just pull it back and forth. Now the interesting bit was with this bottom set of pulleys. What that's doing, these two pulleys at either end, those are driving this with, as I'm sure you figured out by now. Again, if Fusion weren't to crap out on me. Let's go top, let's go, Jesus, Fusion. I do try to avoid opening this file whenever I can, purely because of this. But anyways, so let's get rid of some of the things, just so we can see what we're doing here. So, Jesus, let me see if I can find them. Holy Christ. Oh my God, Fusion, work with me, buddy, my boy. Top mid plate, and feed. Where are they at? Jesus. I'll just click on it. Anyways, yeah, I need a better mic, honestly. This doesn't help that this room is bad, but oh well. So where is it? Come on. Jesus, work with me. Fusion. Dude. Ah, there it is. So I want to get rid of this. And once that goes away. Oh my god. So I guess while we're waiting, I'll discuss a little bit about the construction. So as you may have figured so far, this thing's going to be made out of plywood. It's not just going to be thrown together out of any plywood, though. It's going to be made out of Baltic birch, fancy. But more importantly, it's going to be laser cut is the deal. And that is because laser cutting is just awesome, because you can make big things out of cheap materials like wood fairly precisely. And, you know, if you're creative enough, you can build all sorts of things out of it. So it's very nice, especially, and the machines, you can make them for decently cheap. They're just very nice. Jesus Christ, go away. Jesus, this thing is not liking me tonight. Some days it's better than others. I don't understand it. I just need a better laptop. So it's going to be constructed out of laser cut plywood. I'm using a lot of 1032 mounting hardware, just bolts and stuff. That's why you see a lot of empty bolt holes that aren't populated. Don't want to slow this thing down any further by putting modeling bolts in there that I really don't need to be modeling. That'd be silly. Now, if I were to deselect that, top left V-brace plate. Let's get rid of that. Now, what you can see is, actually, let's go from the top, yeah. Come on, Fusion. All right. So, as I'm sure you've probably figured this out so far, what's making this whole thing work is this little pinion gear and rack teeth pattern I modeled on out of the plywood itself. Now, this is important because, this is important because there's one at either end, and what's going on is that as this thing needs to travel, there would be easier ways to make this middle slider move back and forth, in and out, but a lot of them are limited to one full length of the slides, one full slide length worth of travel, and I want slightly more than that. I shouldn't say slightly, but like 50% more than that or so. And that is a very, very limiting for a lot of designs. This one, however, when you put a pinion at either end, that guarantees that anywhere in this thing's feasible travel, there's always going to be a pinion engaged with the rack. So, yeah, so it's always going to have power to drive it no matter where it is. And one can come disconnected from the rack and the other one will handle it. They're both linked on the same timing belt, so it's not like they're going to come out of time. I am slightly concerned about when it re-enters the meshing, that they might not mesh quite perfectly immediately. But I don't know. I don't anticipate that's going to be a huge deal. And if it is, I don't know. I'll just like sand down the teeth or something silly. But yeah. Now those pinions are going to be made out of UHMW plastic. Again, I might change it to another plastic like Duralin or something. But, you know, UHMW for now. And as well as these blocks down here. These are the guide blocks. I should really jump back to discussing how I'm going to make that pinion, but I'll get back to that in a second. So these guide blocks are UHMW as well, and they are on, if we go to the bottom side, oh man, this computer right here. If we go to the bottom side, what you can see is that there's little slotted holes for those UHMW guide blocks. What this allows is you to slide them up and down, in and out of the of their positions, and this will let me set where they are, and so that I can adjust where that middle slide rides on. Now that middle side is kind of tabbed into the outer rails, and that kind of keeps it moving in and out forward backwards. But most of the weight, because this thing's going to be oriented vertically, is going to be vertically down on these guide blocks. So that's why that's why I wanted some nice, plastic, low friction guide blocks. Now I mentioned that this is going to be hard to make, mostly because I don't want to say a custom gear tooth pattern in size, but because it is, I don't want to say common, but it's one of the known indexes that people use occasionally. However, finding a cutter for it's going to be expensive. I'm considering using a high-speed steel blank and grinding it into shape so I can use it as a single tooth cutter, and just use an indexing head to rotate the UHMW block and cut the teeth into it as I go. But yeah, that's one option. And I could either grind it by hand, which would be really bad, but workable probably, or I could send it to a machine shop and have them make it, professionally, which kind of scares me, but mostly scares my wallet. Yeah, because machine shops can get expensive. However, if I want it to get done right, that's just the way to go, unfortunately. So if I were to jump back a little bit, yeah, we have over on the left. So this is, yeah, that's that. Honestly, it's not a whole lot going on. Mechanically, it's relatively straightforward. Just takes a long time to CAD. Over here, we have the mount for the electronics board panel. This might get revised in the next day or two. But this is kind of it just somewhere to put an electronics panel, so I can make a PCB interface for this thing, and then have it actually manufactured and stuff. So that needed to get done. What else? Honestly, not a whole lot else, admittedly. Yeah, not a whole lot else. That's about it. Mechanical things, honestly, it's not too much to discuss. This is going to be acrylic probably, just so I can laser cut that as well. I might do that on a separate day as the wood though, because I don't have that yet. Again, you may notice, or I shouldn't say again, but you may notice that there's a lot of skeletonizing going on in some of these bars. Most of that's just because this thing's going to be like really big, and I don't want to be carrying around something that's really heavy. So I did a lot of skeletonizing to try keep the weight down. Hopefully, we'll see how that goes. But yeah, other than that, not a whole lot else to talk about. Maybe it's just some material choices like wood, some slight concerns that I might get some warping, but if I do, I guess I could just sand it down or something silly. Other than that, yeah, not too much crazy stuff. It's gonna be interesting. I'm interested to see how this is gonna turn out, because it's my first big mechanical project. That I don't do a whole lot of building myself. A lot of more electronics and coding and stuff, but oh well. Well, that's about all. And I still have no idea how to close these videos, so that'll be good enough.